Hello everyone, thanks for coming. And today I would like to give a summary of the discrete mathematics course for week 2. So first we introduce theorems and proofs in mathematics. So in mathematics, theorem means something that is absolutely true. Proof is an essay to show why theorems are true. So proofs are clarification or explanation. So we have the if-then statement, if A then B. Theorems often go like that. We need to assume a condition. Under that condition, then something is true. So the if-then statement is very important for theorems. If A then B means A is sufficient for B. So if A is true, then B must be true. So we also have the if and only if statement. If and only if B means A is sufficient for B and is also necessary for B. So this means if A then B and if B then A. So they can be both true or both false. So for statements, if A then B, the converse statement is if B then A. The contrapositive statement is if not B, then not A. It is equivalent to the original statement if A, then B. Because if A is true, then if A, then B is true, then if A is true, then B is true. So if not A, then not B. We can, actually later we can prove that. So for disproving something, we usually use counter examples. One counter example will nullify a whole statement. So to find counter examples to disprove this if A then B, we just need to find a case when A is true but B is false. So to disprove A if and only if B, we either find a case where A is true but B is false, or we find a case when B is true but A is false. Next, we introduce the concept of Boolean algebra. So it's a algebra with values true and false for expressions. Here are some basic operations. And x and y is true only when both are true, or x or y is true if at least one of them are true. Not x is true only if x is false. Implication, x implies y is false only if when x is true but y is false. Equivalence, x equivalent to y is true only when both x, y are true or both are false. So they are used to show logical equivalence between Boolean expressions via truth tables. So we need to understand and we need to know how to draw the truth table. So basically we consider different situations and to get the value for an expression. So are some important properties and theorems for the Boolean algebra, the commutative, which means we can exchange the computing sequence for and or. Associative, so it's just like the associative for normal algebra. X and y bracket and z is x and y bracket y and z. Identity, x and true is x, and x or false is x. Double negative is positive. Not x is x. Idempotency means x and x is x, and x or x is x. Distributive, x and y or z is x and y or x and z. X and not x is false, and x or not x is true because one and only one of x and not x is true. De Morgan's law. Not x and y is not x or not y, and not x or y is not x and not y. So we have some terms for Boolean expressions. Tautology means that it is always true in all circumstances for evaluation of all possible values of its variables. Contradiction, it is always false in all circumstances. Contingency means an expression that can sometimes be true, sometimes be false. That's all important concepts we have learned for this week. Thanks for coming.